Okay, so here's what I want to do. So the next thing that we're going to add is actually it's still from module 6, but we just didn't do it with the last testing. The ones you guys are still finishing up. But it's helpful. Knowing this stuff is going to be a little bit, it's going to further give you some more practice, and it gives you just another look at the stuff you've been working on, and so it'll make it better. It'll make it more understandable and give you some additional practice and some additional insight. So what we're doing here is we're going to look at, I think where we left off. Kind of let's look at what we did at the last part of module 6. So 6.4 we did a lot of factoring. Right, we factored polynomials. We factored polynomials with 2 terms using patterns. We factored polynomials with 3 terms using magic numbers. And we factored polynomials with 4 terms the only way we could, which was by grouping, right? And then in 6.5, we learned something that didn't seem to be too connected to that, which was how to divide polynomials, right, using long division or synthetic division. Okay, so now we're going to kind of put those two things together a little bit. So what happens if you're given something like this? If we're given a polynomial like this, where we've got 4 terms, but grouping's not going to work, right? Grouping is not going to work here. If we were to try it, and see if you can tell me why. Can anybody see a reason why grouping isn't going to work there?
It's not even on both sides.
It's okay. I think it's by even you mean the same kinds of ratios? Yeah, it's not. If we try to do it, it's just not going to work. If I factor out a greatest common factor of the left group, what is it?
X squared.
X squared. And then that leaves me behind with what? If I divide x cubed by x squared, I get x. 11x squared divided by x squared is 11. Okay, good. So that's what I get from the first group. Now, what about the second group? Well, I can't get an x plus 11, can I? The only thing I could potentially factor out would be just a 2, right? And I'm not going to have the same leftover, which I needed, right? That's going to leave me with 38x divided by 2 is 19x, and 40 divided by 2 is 20. So that doesn't do me any good. I don't have any common factors in the groups, right? So I can't do anything with that. Grouping didn't work. So I need something else. Okay, well for now when we get into the next module, we're going to actually look at some ways where we could do this without being given a hint. But for now, we're going to be given a hint. So they're going to tell us in this case that maybe x minus 1 is a factor of this function. And we'll check to see if it actually is. And if it is, that would allow us to factor this thing completely. If it's not, then we just put in n and go on to the next problem. Because look what the instructions say. They're saying if the binomial given is a factor of f of x, then keep going. If it's not, then we're going to just enter n. Okay, but let's think about that language for a second. We're going to check to see if x minus 1 is a factor of f of x. Before we jump into doing division of polynomials like that and seeing if a polynomial is a factor of another polynomial, let's think about it in terms of numbers. I'm just going to throw some numbers out here. Is 6 a factor of 30?
Yes.
No.
It is. How come?
Because 6 times 5.
Oh, okay, because it divides in evenly. It divides in 5 times. Is 10 a factor of 30?
No.
Yes. 10 divides into 30 evenly, right? Is 9 a factor of 30?
No.
It's not, because 9 does not divide into 30 evenly. So it's not a factor of 30, right? So if x minus 1 is a factor of x cubed plus 11x squared plus 38x plus 40, then what must be true? X minus 1 must do what? Divide into it. It must divide into f of x evenly. Meaning, what's the remainder going to be? 0, right? 0. So all we've got to do then to check this out is just see, is x cubed, does x cubed plus 11x squared plus 38x plus 40 divided by x minus 1 work? Do we get no remainder, right? So we got a couple ways to do this if we go back to 6.5. We could use long division, right? That's hard. Long division, there's a lot of stuff going on, a lot of moving parts there, a lot of places to make a mistake. Fortunately, we don't have to use long division. What could we do with this? we could do synthetic division. We can do synthetic division because the bottom is linear, right? The bottom is, it doesn't have any x squareds or x cubes. The biggest power is just x, right? So let's go through that process, remind ourselves how that works. If I want to do this division problem, I want to simplify this quotient. When I use synthetic division, I've got to make my bracket. So what are the numbers that go here?
1, 11, 38.
Okay, 1, 11, 38, and 40, and there's my remainder box, right? What's the number that goes out front? Okay, yeah, -1 is what people pretty much want to say, because it makes sense, because there's your -1, but the answer is 1. How come?
Because the x is, you gotta equal to 0.
Okay, because we want to find the 0 of the denominator. When we use synthetic division, we want to find the 0 of the denominator. And the 0 of the denominator is two ways to think about it. It's either going to be the value of x that makes the bottom 0, or I could just set it equal to 0 and solve. It's really the same thing. What do I get for an answer?
Oh, sorry.
What's the value of x that makes the bottom 0?
Positive.
Positive 1, right? So we get 1. Okay, and then we'll just try this out. We'll see if this is a factor of f of x. So what were the steps in doing synthetic division then?
Bring down the first.
Bring down, okay, first thing is we're going to bring down the 1.
Many times 1 by 1 in the box.
Okay, good. Whenever a number appears below the line, we multiply by the number in the bracket. So 1 times 1 is 1, which we put in the next slot, right? And then we add, right? It's opposite of long division. We're always going to add. So 11 plus 1 is? 1 times 12 is? 38 plus 12 is what, 50?
Oh, it's 50.
And then 1 times 50 is 50. 90. Didn't work, did it? Okay, so it's not a factor. So what would we enter in Moodle? 10. Yeah, it's not a factor. Okay, let's try another one. Same thing here, same kind of problem. This time they're saying, okay, what about x plus 3? Is x plus 3 a factor of this f of x? Well, let's just see. We don't need to write down the whole quotient. We'll just jump right into synthetic division, right? So, just like before, there's our bracket. So, Ariel, what number goes in there? -3, good, because it's going to be the 0 of x plus 3, right? And then the coefficients are?
1, 3.
Good.
So is the f of x -4x?
So is the, what f?
F of x.
So f of x is just this whole function, right?
So then with the last one, how is that 90?
Oh, and the last one?
Yeah.
Well, in the last one, we tried to see, we just did this quotient to see if x minus 1 divided evenly into f of x, right? And it didn't, because we got a remainder,
Oh.
right?
So
So we don't
that's
even need to
0.
write out what this is. We just needed to see if we got a 0 in the remainder box, and we didn't,
Oh, okay.
right? So it's not a factor, so we just, n was the answer. So we'll try here, how about? So we bring the 1 down, 1 times -3 is, so add those up, I get 0, -3 times 0, 0, -4 plus 0, -3 times -4, and it worked. We got 0 this time in the remainder box, right? Okay, so it did work. So what's that tell us? That tells us that yes, x plus 3 is a factor of f of x, and when we divide them together, this is the result. Now let's think about that in the context of numbers, right? So let's go back to the example, let's take the 6 and 30, right? So 6 is a factor of 30, right, because it divides in evenly. What's the other factor that multiplies by 6 to get 30? 5. And we get that by just dividing, right? 30 divided by 6 is 5. Okay, so let's apply that same logic to this problem. So now we know that yes, x plus 3 is a factor of f of x. What's the other factor that's being multiplied by it? Well, it's got to be the answer, right? Does that make sense? So then we know that this f of x is going to break down into x plus 3 times right? It's gonna split apart into x plus 3 and then this factor, right? Well, how do we interpret that one? There's no remainder. What does that negative 4 stand for? Right, what do all those numbers mean in the answer? Well, it's the answer, but what are they? They're the coefficients, right? They're the coefficients in our answer, starting with the constant and then working our way towards more powerful, bigger powers of x. So there's the constant, there's the coefficient of what? Of x. There's the coefficient of x squared. If we kept going, there'd be the coefficient of x cubed and x to the 4th and so on, but it stops at x squared, right? So we just end up, really, this is just 1x squared plus 0x minus 4, right? So there's our other factor, x squared minus 4, right? Look what we did. We broke our original polynomial up into a product of the factor that we were given, x plus 3, and what we got when we divided it into the f of x, which was x squared minus 4, right? So now it tells us just to write this in factored form. So are we done? That one's done, but is that one done?
No.
No, it's not quite done. That's got 2 terms, so if I want to factor a 2-term factor further, break it apart further, how do I do it?
Difference in square root.
Difference of squares. We've got to use the sum or difference pattern, and that's a difference of squares, isn't it? X squared minus 4 squared is really just x squared minus what squared? Or 2, right? So then x squared minus 2 squared, if that's a difference of squares, how does that break apart? There you go. X minus 2 times x plus 2, and then out front we've still got our x plus 3. So that would be our answer, right? There is our original polynomial f of x in factored form, broken down as far as we can break it down into factors, right? Now, what if the question had asked what are the zeros, all the zeros of that function? Well, negative 3 would have been 1. What are the other two?
2, negative 2.
Positive 2 and negative 2, right? Good. Okay, let's try one more. How about something like that? This looks a little different, right? This time they're saying, okay, completely factor the polynomial and write the polynomial in factored form, right? Okay, so it's the same type of problem, but they're giving us a little bit different information here. So what does this mean?
X equals negative 2.
Okay, so negative 2 is a value of x that makes the function 0, right? So what's another way of saying that? That negative 2 is a what of the function? What would we call that? Well, what do we call the values of x that make a function 0? We call them zeros, right? So that's a 0 of the function, right? That's a function, that's a value of x that makes it equal to 0, right? Now here's what I want you to see, and there's a big fancy theorem in section 6.5 that we didn't really cover, and I don't even think I'll even pull it up because you'll see the name is the factor theorem, but big deal. Just want you to see what it does. If I know that negative 2 is a 0 of the function, what's the factor that goes with that? Right? Let's think backwards here. In the past, what have we done? Like in this last example, look what we did. We weren't given any zeros. We were just given a factor, right? When we got this thing into factored form, if we wanted to know what were the values of x that made this function equal 0, well, we could have just set the whole thing equal to 0, right? And I could have solved it by the zero product property. So what's going to be the value of x that makes that factor 0? Negative 3. Okay, so this gives us x equals negative 3. This one gives us x equals 2. And this one gives us x equals negative 2. So those are all the zeros of the function, right? So what did we do? Well, we just subtracted. I mean, all we did was we just said x equal to 0, right? What if we had to go the other way? That'd be easy. What if we knew that negative 3 was a 0? How could I find the factor that goes with that? Kind of the opposite. Really all I'm doing is I'm just subtracting this from x, right? What's x minus -3? X plus 3, right? If the 0 is 2, then x minus 2 is the factor, right? If the 0 is -2, then x minus -2, or x plus 2, is the factor that goes with that. See what I'm saying? Okay, so then, in this problem right here, if we're trying to turn this into factored form, if they give us this 0, yes, then it's going to be, well, it's going to be x plus 2, right, is going to be the factor. So this 0 goes with the factor x plus 2, because that's the factor we could set equal to 0 to get that answer, -2, right? See what I'm saying? So we know already then that this, in factored form, this function is going to equal x plus 2 times something else, right? How do we know what the something else is? Divide, right? We'll just divide. We'll divide the whole function by x plus 2 synthetically. Same thing we just did. Okay, so let's try that one more time. So there's our bracket. Now be careful, which number goes out here? No, -2. We want the 0, right? Not the factor, we want the 0. So they actually made it easy on us. They gave us the 0 this time. So -2 is the 0. So that goes in the bracket, right? What are the coefficients? 12, -19, and 26, okay? We already know what goes in there. 0. We know that because look what it tells us. It tells us -2 is a 0. So that has to be 0 automatically, right? There's no other thing it could be. If it doesn't end up being 0, we messed up the synthetic division. So let's do the synthetic division. I bring the 12 down. -2 times 12. So -19 and -24 is what? -43. -2 times -43. 86, positive 86. -73 plus 86. What's it gonna be? 13's right. And then -2 times 13. 26. -26, right? And so it worked. We got 0. Okay? So what's that tell us then? What's the other factor going to be? We know one factor is x plus 2. What's the other factor? It's right there, isn't it? Right? What is that? How do we interpret that? Those are the coefficients, right? So that 12 is the coefficient of what in this case? X squared minus 43x plus 13, right? Everybody agree? Okay, so then that's what would go right here. Oops. $12x squared minus 43x plus 13. Okay, so now the question is, can we go any further, right? So we've got it broken down into a product of these two factors. That one's kind of ugly, right? It's a quadratic factor, and it's got, a is not equal to 1, it's equal to 12. So what are our options with that? It's not, we didn't do a lot of that. Okay, we can factor it, but how do we deal with factors where a is not equal to 1? Those were the harder kind. What was our trick for that, remember? What was that? Well, I mean, but it tells us to factor it, so we have to know if this breaks apart again. If a is equal to 1, we just look for magic numbers, right? But if a is not equal to 1, we still look for magic numbers, but we got to use bottoms up, right? The numbers get a little bit harder. So if we're going to use bottoms up, let's just review that, because we're going to start using that a little bit more now. So with bottoms up, the two magic numbers we get have to be the numbers that multiply to AC and add to B. So what's A times C? 12 times 13? What's 12 times 12? So 13 times 12 would be an extra 12. So what's that going to be? 156. So then they're going to add to B, which is negative 43. Can we find numbers that multiply to negative 156 and add to negative 43? Well, I don't know, maybe. Let's see. I think we can. Yeah, I see what they are. Can you find numbers? If they're going to multiply, so with bottoms up, what are the signs going to be? We're going to start with x's there. What are the signs going to be if they multiply to a positive and add to a negative? They're going to multiply to a positive and add to a negative. Negative and negative, okay. So now we just got to find numbers that multiply to 156 and add to 143, both negative, right? So let's think about that. So we got 156 and 1, we'll make them negative. Well, that's not going to work. They added something way too big, right? So I could cut that in half and multiply by 2, and that would be what, 78? Negative 78 and negative 2. Okay, that's not going to work. 3 goes into that, I guess. So 3 goes in, what, 52? Still too big. What about 4, though? If I cut that number in half and double that one, see what I'm saying? If negative 78 times 2, then half of negative 78 times negative 4, right, would also be a factor. Well, what's half of 78? 39. So we could have negative 39 times negative 4, and that works, doesn't it? Okay, that one's going to work. So now we see what the magic numbers are. So the magic numbers are 39 and 4, but remember what we do with bottoms up. The only difference, it's the same as it always was with regular magic number trinomial factoring, except this time we're going to divide each of the magic numbers by whatever the number in front is, right? So it's 12, right? Whatever A is, we're going to put that on the bottom. And then we're just going to reduce those fractions and go bottoms up, and we're done. So does 39 over 12 reduce? Yeah, 3 goes into both, right? So what is that going to reduce to? That's going to reduce to x minus, what, 13 over 4? Okay. And then over here, 4 over 12 is just 1/3. Okay, so if we end up, after reducing, if we end up with a fraction, remember, all we have to do is go bottoms up. Whatever the denominator is, that's going to get pushed up in front of x, and we're done. So we'd end up with 4x minus 13 times 3x minus 1, right? Okay, does that make sense? Okay, and so that's what this guy's going to break down into by using bottoms up. So our final answer then would just look like, let's do this. So we left off there. So what does that break down into further? Okay, so we know that this guy's done, but this guy broke up into those two factors, right? So 4x minus 13 and 3x minus 1. And then we'll be done. So bottoms up is a little tricky, right? There's a lot to that. There is another way you can do this. It's kind of like legal cheating. There's a way you could do this also. You could, we could find out, if we were just looking for the zeros, we could find these pretty easily, right? We'd know this one is -2, and what if I were trying to solve the equation, set this factor equal to 0? If I set 12x squared minus 43x plus 13 equals 0, and I want to find the solutions I don't have to factor. Factoring would be too hard there. What would I do instead? If I want to solve a quadratic equation, what can I always do? Put it in the quadratic formula, yeah. If I've got a quadratic equation in standard form, the quadratic formula will always give me the solutions, right? So in this case, we're going to find the zeros of that factor by setting it equal to 0. So let's do that, see what we get. If we apply the quadratic formula, A is 12, B is negative 43, and C is 13, right? Okay. So then we would just get x equals negative b, so that's 43 plus or minus the square root of negative 43 squared. I don't know what that is. We'll find out though. $18.49 minus 4 times 12 times 13. All divided by 2a, so 2 times 12. Okay, what's that give us? If we just do the calculator work here, what's that give us? We get square root of 1849 minus 4 times 12 times 13 is 35. That all works out to be 35. So we get 43 plus or minus 35 over 24. If we take the plus, 43 plus 35 is 78 over 24, which is going to reduce. 78 over 24, let's see what that gives us. Well, I'll cheat. We use a calculator. So that's going to give us 3.25, so that is 13/4. I do. I do like math. If we take the minus, we'd get 43 minus 35 is 8, right? 8 over 24 is 1/3. I want to see, can you tell me how we could turn those into those solutions? We can do this. Yeah, really all it is, right? We know if these are the zeros, what was our recipe for finding factors, right? If we know what the 0 is, all I've got to do, I need a new color here. I guess we'll use that one. I haven't used that one yet. So we could take x minus our 0, right? If that's the 0, then we'd get x minus 13/4, right? But that's not very convenient because it's a fraction, right? All I'd have to do is go bottoms up. In fact, if you look up here, look what I had right there. X minus 13/4. See what I'm saying? So if we just go bottoms up here, we get the same answer that we got before. What about down here? If I take x minus 1/3 and I go bottoms up, looky there. That's what we had, right? It's 3x minus 1. So we don't even have to do bottoms up. You could always cheat and just work backwards and use the quadratic formula. And if you get answers that are fractions, go bottoms up, right?
Does that work every time?
Works every time. Every time. All right. Okay, that's all I think I've got for you. I'm going to let you guys work a little bit.
Okay.
The assignment's up, all right? I want you to do at least 2 problems from the 6.5 practice 2 assignment. Then you can work on whatever you want, okay? Grab Chromebook. Have at it.